friends, today's video is about printed circuit boards. This presentation delves into the world of printed circuit boards (PCBs), exploring their fundamental nature, manufacturing processes, and diverse applications. Understanding the basics of PCBs. What is a PCB? A printed circuit board (PCB) is a foundational element in electronic devices, acting as a foundation for electronic components. Essentially, it's a flat, rigid, or flexible board made of insulating material with conductive pathways called traces etched on its surface. Importance of PCBs. PCBs are vital for interconnecting electronic components, providing a reliable and efficient way to establish electrical connections. They streamline the assembly of complex electronic systems, reducing wiring and improving performance. The anatomy of a PCB. Copper layers. The conductive pathways or traces are made of copper, which is etched onto the board surface, forming a network of interconnected paths for electrical signals. Insulating material. The board's base is made of insulating material such as fiberglass or epoxy resin, which prevents electrical currents from passing between the copper traces and the board itself. Components. Electronic components such as resistor, capacitors, integrated circuits, and connectors are mounted onto the PCB, establishing connections with the traces. Materials used in PCB manufacturing. Copper. Used for the conductive traces, copper provides the path for electrical signals to flow. Fiberglass. Offers strength and rigidity to the PCB, making it durable and capable of supporting electronic components. Epoxy resin. Acts as an insulating material, preventing electrical currents from short circuiting. The PCB design process. Design starts with a schematic diagram which outlines the electrical connections and components of the circuit. The schematic is then transformed onto a physical layout, arranging components on the PCB and routing traces for connections. The layout is reviewed and verified to ensure correct connections and avoid any potential problems. Once the design is finalized, it's sent for manufacturing where the PCB is created based on the approved design. PCB manufacturing techniques. Etching. Chemical process removes unwanted copper from the board, leaving only the traces that connect components. Drilling. Holes are drilled through the PCB for components that require through-hole mounting. Component placement. Components are carefully placed onto the board, either by hand or using automated machines. Soldering. The components are attached to the PCB by soldering, creating a permanent electrical connection. Surface mount technology versus through-hole. Surface mount technology, it is also called as SMT. Components are mounted directly onto the surface of the PCB with leads soldered to the traces. This method is relevant due to its efficiency and compactness. Through-hole. Components are inserted into holes drilled through the PCB with leads extending through the holes and soldered to the traces underneath. This method is older but remains suitable for certain type of components. PCB testing and quality assurance. Automated testing. High-speed testing machines verify the electrical connections and performance of the PCB. Visual inspection. Human inspectors scrutinize the board for any defects such as missing components or incorrect soldering. Functional testing. The PCB is tested under operating conditions to ensure it meets performance specifications. Common applications of PCBs: consumer electronics, automotive, medical devices, and industrial automation. The future of PCB technology. Miniaturization. PCBs are becoming smaller and more intricate, allowing for denser component packing and more compact devices. Flexibility. Flexible PCBs are increasingly common, enabling the creation of devices that can bend and conform to different shapes. Advanced materials. New materials are being developed to enhance the performance, durability, and thermal properties of PCBs. Integration. PCBs are becoming more integrated, incorporating multiple functions and capabilities into a single board. If you like my video, then please do like, share and subscribe to my channel. Thank you.